Hi guys, this is Miss Wesley again, and we're going to focus today on the volume of what's known as composite solids. Alright, so our essential question for today is how do we find volume of composite solids? And then a second question related to that is when do we add or subtract volumes? Because we're going to have to do one or the other each time you have a composite solid. So take a second to copy that down for me. So after you've had that copied down, like I said, our focus for today is going to be all about composite solids. And composite solids are when you have one or more shapes put together in some sort of way. So our steps here are going to be that you first must find the volume of all the shapes. So that's always step one. And then you're either going to add the volumes or subtract the volumes. Okay, and that depends on the scenario, on the type of composite solid you have. But again, step one is to always find the volume of all the shapes, and then you add or subtract depending on what you have. Okay, so here we have two examples of composite solids. So if you notice here, on the one on the left, we have our cylinder on the bottom. And then on top of that, we have half of a sphere, or a hemisphere. So since these two things are glued together, or for instance, when the shapes are stacked on top of one of another, we must always add the volumes. Okay, because essentially you're putting two shapes together. So you're taking the volume of one shape plus the volume of the other. The other scenario is when we have shapes that are within one another. So for instance, we have this cube here, all right, as you can see, and then we have this cone. But this cone was almost like drilled out of that shape, so there's a hole in the middle of that cube now. So if that's the case, we must subtract the volumes. Okay? And a way you can think of that is you're taking the one shape out, so you have to take out that volume. Alright, so let's make our way down to an actual example so we can see how you would have to go about this in a problem. So it says a composite solid is made up of a cone and a cylinder. So right away you know the two shapes that you're dealing with. It says the slant height of the cone is 25 centimeters, and my pen really doesn't want to work tonight. There we go. And you can notice that this is the slant height, okay? It's called the slant height because it's on the slant of the shape. It says the height of the cylinder is 15 centimeters, and its radius is 12. The height of the solid, okay, notice the key difference here, the solid is 37 centimeters. Find the volume of the shape to the nearest tenth of a cubic centimeter. So when we go about these problems, you always want to break it up into the two shapes you have. So I'm going to start with the cylinder. Okay, so step one is I'm going to find the cylinder. So again, if I look on my formula sheet, I'm going to see my volume of a cylinder formula is pi r squared times h. So again, the problem told me that the radius here was 12 and the height of my cylinder was the 15. So I'm going to go ahead and plug in. V equals pi times r, which was 12 squared, times the height, which was 15. So notice that I have a pi there. I'm going to go ahead and do what we did last time, which was leave it in terms of pi for right now. So I'm only going to type in the 12 squared times the 15. And in doing so, I'm going to end up with 2,160. I'm going to stick a pi back on it at the end. Okay? So that's my volume of the cylinder. Well, now I have to go ahead and find the volume of my other shape, step 2, which is the cone. Alright, now if you started with the cone and then went to the cylinder, that's fine. There's nothing wrong with whatever order you work in here. So I'm going to look at my formula sheet, and I'm going to see that my volume of a cone formula is 1/3 pi r squared times h. So you might be saying, well, what's the radius, Miss Wesley? Well, the radius of this cone is going to be the same as the radius of the cylinder. So my radius is still going to be 12. So V equals 1/3 pi times 12 squared. But now I need the height of just the cone. So I'm going to look back and say, okay, I need the height of just the cone, just this piece. Well, I know the overall height here is 37, and I know the height of the bottom was 15. So if I subtract those two numbers, that would leave me with a height here of 22. And then I got that from doing 37 take away 15 leaves me with 22. So that's going to be the height that I use here. Okay. And just like I did before with the cylinder, I'm going to go ahead and type in everything just except the pi. When I do that, I'm going to end up with 1056. And again, don't forget to stick the pi back on it. All right, now I have my volume of the two separate shapes. So here's the last step that's new to us. I have to find step 3. Really need a new pen. Is the total volume. So in this case, since our two shapes are essentially glued together, we're not like drilling a hole or taking one shape out of the other. That means that we're going to need to take the volume of the cylinder. That's supposed to be an L. What did I just do? Try that again. Cylinder plus the volume of the cone and add them together. So my cylinder was right here. So I'm going to take 2160 pi plus 1056 pi. Oh goodness, this pen. All right. And if I add those two together, we are going to get 3,216 pi. However, the question said nearest tenth of a cubic centimeter. So now that I have this, I'm going to type this in my calculator and use the pi button. And in doing so, this allows me to wait till the very last second to round. So 3,216 times pi, we are going to get 9,820.6186. There's a bunch of other decimals. All right, so again, nearest tenth would mean I want one decimal in my answer, so I look next door. That one's not going to do anything. So my final answer, I'm out of room, hopefully you guys have space, is going to be 9,820.6. And that's my final answer. Again, I'm not putting units on it because I don't want to run the risk of potentially getting that question wrong, all because of units. But this was a perfect scenario of where we have one shape. We had a cylinder, so I found my volume of that cylinder. I had a cone, so I found the volume of that cone. And then because these were glued together here, I simply added them up. Again, I waited to do pi until the very end, so I didn't round early. And in doing so, we got ourselves a final answer. All right, let's go to example 2. Okay, so in this example, it says a wooden toy is made up of a cone attached to a hemisphere that has a diameter of 10 centimeters. The slant height of the cone is 13. What is the volume of the toy? Round your answer to the nearest cubic centimeter. So again, when you see those words, it means no decimals in our answer. So I'm going to start by drawing a picture since it didn't give one to me. So we have a cone. Looks like that. And we have a hemisphere. All right, now hemisphere is just half of a sphere. Okay, so I'm going to kind of attach a rounded shape to the top of that. Pretty good. So it says our diameter was 10. So that means from one edge of the cone to the other is 10. But if I think about my formulas, I never really want the diameter. I'm always concerned about the radius. So if my diameter was 10, we know the radius is going to be 5. Okay. Now it said the slant height of the cone was 13. So thinking back to that last problem, the slant height right here is going to be 13. But in all of our problems, we need the actual height, which is straight down from the middle of the cone. Well, since it's a cone, it's a right circular cone, I'm going to know that there's a right angle here. So we're going to actually have to solve for the height before we go much further with this problem. So meaning I'm going to put a little h there, and that's what we need to take a second and solve for. But if you look at this, I have myself a right triangle. I know 2 of the 3 sides, so we're going to think back and say, okay, what formula can we use for right triangles when I'm dealing with all sides? Oh yeah, that's right, Pythagorean theorem. A squared plus b squared equals c squared. All right, so we know 13's got to be our hypotenuse, so I'm going to put 5 squared plus b squared equals 13 squared. 5 times 5 gives me 25 plus b squared. 13 times 13 is 169. Okay, doing a little bit more math here. If you subtract that 25 over, you're going to get b squared equals 144. So that means b, if we square root both sides, is going to be 12. Okay, so step 1, that we didn't normally have to do this, but step 1 here was find height of cone. Okay, now that we have that squared away, we can actually go back to dealing with the volumes of our individual shapes. So we know we have a cone, so I'm going to write out step 2 now is to find the volume of that cone. So again, from our formula sheet, we know that the volume of a cone is given to us. V equals 1/3 pi r squared times h. So let's plug in 1/3 pi. Our radius was 5, so 5 squared times our height. Now be careful, we have to use that new height, which was 12. Alright, so again, just to be a little bit more accurate here, I'm going to type in everything without the pi in it, so just the 1/3 5 squared times 12. In doing so, I'm going to be left with a nice even 100 pi. Alright, so we found the volume of our cone, but we have to go back now and find the volume of our hemisphere. So step 3 is we have our hemisphere. I'm going to put hemi just because I'm running out of room there. Alright, now if you look on the formula sheet, there's not a formula for a hemisphere. But oh, hey, I know that the hemisphere is just half of a sphere, so I'm going to use our sphere formula and then just cut my answer in half at the end. So if you look on your reference sheet again, okay, this time under sphere, you're going to see V equals 4/3 pi r cubed. All right, again, the radius for the cone is the same as the radius as the hemisphere, so substituting in, V equals 4/3 pi times 5 to the third. But again, I can't forget here that if I was to plug all of this in right now, I would get the volume of a full sphere. I only want half of that. So what I have to do is I have to divide everything by 2. So in your calculator, you might need to put an extra set of parentheses here, just so your calculator knows that that's your numerator and 2 is the only thing that should be in the denominator. Double check for me when you go to hit enter that it does in fact look like that. Make sure it doesn't just do like 5 to the third divided by 2, because that is a common thing that does happen with these. So after you've typed that in, okay, and again divided it by 2, you should end up with, it's not going to be nice this time, meaning like I'm not going to have pi left, especially because we have that 4/3 in there. You're going to end up with getting like 261.799. Alright, and again, I'm not rounding that early to the nearest cubic centimeter like it says up here, because that's not my final answer, remember. So the last step here is we need to figure out what we want to add or do we want to subtract these volumes. Well, it's set up at the top of the wooden toy is made up of a cone attached to a hemisphere, so meaning that they would get glued together. So our final step is to go ahead and add the volume of the cone plus the volume of the hemisphere to get our total volume. So fourth step, again, I'm out of room, I apologize. Okay, is to find our total. So I'm simply going to write cone plus hemisphere. I'm going to shorten that. So in your calculator, what you should be typing in is 100 pi plus 261.779. Making sure that the hundred's the only thing with the pi, the 261.799, you're not rounding that. And then when you do that, we are going to get an answer of 575.95826. So that looks wonderful. However, again, it says round to the nearest cubic centimeters, meaning I don't want any decimals in my answer. I am so out of room. Hopefully you have some space left. I'm going to go way up here in the top left, which I hate doing. But I need to round this nearest whole number, so I look at the 5 because it's my last digit. I look next door, which is a 9. That 9's going to bump my 5 up. So our total volume here would be 576. Again, I apologize for running out of room. Okay. So these composite solids are essentially the same thing that we've been doing. You're now just doing more than one shape per problem. Again, adding or subtracting depending on the scenario. Okay, friends, here's our last example for this, and then you're going to get to practicing, and I do mean practice. Don't skip it, please. All right, a candle holder is in the shape of a cube with a cylindrical hole through the middle. All right, so I boxed that word hole for a key reason because that's telling me that the cylindrical piece is taken out of, it's drilled out of the cube. So meaning there's going to be a hole left, which means empty space, which means we're going to need to subtract. It says the edge length of the cube is 15 centimeters. The height of the cylindrical hole is 9 centimeters, and its radius is 2.5. Find the volume of the candle holder to the nearest tenth of a cubic centimeter. So again, always break this up into your different shapes. Okay? Shape 1 is a cube. Can you see that green? I hope so. All right, volume of a cube. It's not given to you. But you have to think to yourself, wait, the volume of a cube, all these side lengths are the same. 15, 15, 15. Oh, that's right. I do V equals length times width times height. So 15 times 15 times 15. Or essentially 15 cubed. Ha! Get it? All right, so when you type in 15 times 15 times 15, you will end up with 3,375. All right, there's our cube. But we know we have a second shape, and it was a cylindrical shape, keyword being cylinder. So my second shape is a cylinder. Again, cylinder formulas are given to you. You don't have to memorize them. V equals pi r squared times h. So I'm going to plug in the numbers that I know. V equals pi. The radius of my cylinder was 2.5. The height of my cylinder, now be careful, it's not the height of the cube, it's the height of the cylinder, which they told us nicely was 9. So I'm going to go ahead and type that all in all at once. Yes, you could leave it without the pi if you wanted to, but since there's no pi in this number down here, I'm going to go ahead and type this one in completely. So when I do that, I'm going to be left with 176.7146. Okay, again, notice I'm not rounding that because that's not my final answer, and you don't want to round halfway through a problem. You only want to round at the very end. So our third and final step here is to find the volume of the candle holder. And we already talked about how there was a cylindrical hole drilled out of the cube. So that's going to be a big clue that I need to take the volume of the cube and subtract away the volume of the cylinder. All right, and again, I'm subtracting because that piece is coming out of the cube. That piece isn't there anymore. So my volume of the cube, again, if I look up above here, was 375. So 300, oh my goodness, there we go. 375. Minus the cylinder, which was 176.7146. All right, and again, type that in your calculator. We are going to end up with 3,198.2854. And the last thing I have to do is it said to the nearest tenth of a cubic inch. So I look at the tenths place, I look next door, it's an 8, so that 8's going to bump up our 2. So my final answer here, 3,198.3. Box that in. And we are done. So composite solids, again, it all depends on what your shape is. Are you adding shapes together? Are you subtracting shapes? And if you're ever unsure, call Miss Griffin or myself over, but try and use the context of the problem and the key words to help you figure that out. All right, see ya.